Welcome to another video. Today's learning objective is to construct and interpret plans and elevations of 3D shapes. So this topic is all about visualization, and it depends on kind of how good you are, I guess, at doing it. And if you're not so good as I am, I'm not great at these kind of visualization stuff. What's really important is that you practice these kinds of questions because they take a while to get used to and to get the hang of, I guess. But with questions such as these, there's three pieces of terminology that are quite important that you need to know. So let's suppose I kind of draw a house, let's say. Or actually, let's hold on. Okay, let's suppose I have this kind of deodorant. Okay, so this is a 3D object, right? But there's potentially a way to represent this in 2D. We've kind of got our representations as we've seen before. Remember, I drew a cuboid with kind of those dashed lines, etc. But you can also perhaps, represent, the three major points of view in 2D. So you could represent a view for, say, kind of looking at the object from top down. So if I show that to you like this, you can see, this is the view you might get. You're looking at the object top down, and that's a bird's eye view. That's what we'd call a plan view. If we kind of look at the object kind of straight on, and we see the front of it, we'd call it the front view. And if we're looking at the object side on, that's a side view. So every time you kind of look at each of these, for example, with a plan view, you've got kind of you can create like a 2D representation of it, right? So you can see what's happening here. You can draw whatever you're seeing like this in a 2D plane. And same thing with kind of here. You can draw whatever is happening here in 2D plane, and same with this view. And having those three views, you should, theoretically be able to construct a 3D model, and that's basically what there is to it. You have to kind of do this from going from kind of those three views into a 3D model and vice versa. So I'll draw another thing out to help solidify this understanding. Suppose I have a house, and it looks something like this. You've got a house. Ooh. And I'm sure it's got a roof. And if we extend it, so it's a house something like this. A very badly drawn one, if I might say so myself, but okay. Let me say it's something like this, right? So say this is a house. And say, there's a door here, so, say there's a door like that, and there's a few windows here. So if we were looking kind of, at a view like this, we might call that the front view, as I said. If we're looking at the side, this might be the side view. And if we're looking top down, as in a bird's eye view, that'd be a plan view. So let's think about what does this house look like kind of from the front? Well, the front view would be kind of, we'd have that rectangle and something above it, right? So we'd have, suppose you're kind of looking at your house sideways, think about what that might look like. So just pause the video, try drawing this out for a second. So the front view might look like something like this, right? So we'd have, this rectangle like this, which is kind of represents this part of the house. And then, you wouldn't, in a 2D thing, you wouldn't be able to tell that the roof is kind of slanting backwards. So you'd have you might see a line here, for example, with different materials or something, but you'd again just get kind of another line up here, and then you might see that you'd see the door as well. So this is the front view. The side view, well, the side view might be something like, because you see that on the side you can actually see the triangle itself. So you'd see kind of something like this. And maybe you'd see the windows. And looking from a bird's eye view, again, when you convert a 3D space into 2D space, you lose that kind of that third dimension, of course, right? So in this case, you don't have any perception of depth when you're looking from a plan view. So you just have something like a great big rectangle, and you might be able to tell kind of that this is the peak, for example. So this might be the plan view. Side view. So this terminology is quite important and it comes up, but we'll move on to a few questions to kind of see how it goes. So this is the first question. Okay, so this is the first question. And so we've got the diagram showing the plan view, the front elevation, and the side elevation. So sorry, sometimes instead of saying view, they might say elevation of a solid shape shown on a centimeter grid. So important here to note that's a centimeter grid, so which means that each kind of square on the grid represents a centimeter. In the space below, draw a sketch of the solid shape and give you dimensions of the solid on your sketch. So this is actually quite a common thing to do, to be asked for the dimensions. So a quick thing to do worthwhile is just on this, just label some dimensions. So you know this is say 3 long, right? So this is 3 centimeters. This is 2 centimeters. This is again 2 cm. That is 4. Is that 4? 1, 2, 3, 4 cm. And this is 2 cm. And then kind of you've got, what is that? 4 by 3 cm. And the way I like to do these questions is first thing you have to kind of do is almost visualize it in your head, and that is a struggle sometimes. So it's a bit of a puzzle. So first thing I tend to do is I look at the front elevation, and I think, okay, so the front of a shape will kind of look like this, right? That doesn't mean it's necessarily going to be necessarily like, it's going to be a straight object, straight up like this, right? There might be some sort of slant to it. That's what you have to realize first. But at least that the front of the shape will look like this, but kind of tilted, possibly. Either kind of this way or that way. And since there isn't a solid line, that's not kind of necessarily a break. That's what suggests that there's some sort of a break. Where if there's no break, it's more of a slant, if you kind of get what I'm trying to say. So if we go back to our house, when we see something like this, right, we know kind of it goes down like that. So kind of there's the gradient of that shape changes. And same thing here, right? So this part here is completely straight up, and then here, because of this line, the gradient changes. So you have to watch out for that. But as it's great to see with the front elevation that there's no kind of break in that change in gradient. So it's just going to be this trapezium shape, but with some sort of slant to it, right? So it could be the trapezium, going down like that, or coming back up towards me. Now that I've seen it from the front, I know it's some sort of slant like that. I have to see how this fits in with the side elevation of just completely flat. So that means if you looking this way, you see a trapezium with some slant, and looking this way, you see a rectangle with some slant. And the only way you can the way you can combine those two is just having some sort of slanted trapezium and another slanted side rectangle. So you've got a trapezium on the front, and then it's kind of a front elevation on the side. So now that you have that, you have to think about how those two fit together. So you can kind of think about bringing this shape here, and then think about, for example, maybe even adding it like that there. So that's one thing you do kind of straight away. And now you see how this kind of fits in with the top now. Well, there's going to be some sort of change in elevation here, or not elevation, gradient. So this is kind of a flat 2 cm thing, and then a change downwards. And so this flat 2 cm thing kind of fits well with this flat 2 cm up here. So you have a 2 cm thing up going like that, maybe. And then it changes in elevation, so this is kind of that. So, overall, it would be kind of, looking from the top, this is 4 cm long, right? As that fits with the bottom being 4 cm. And then you've got kind of, you have it like that. And that's kind of, all there is to the shape, I guess. You know that this rectangle will be copied over here, and this front elevation will be copied over here. So that's basically the shape. And now you just have to kind of draw this a bit nicely and label everything. So, this will be a bit of a struggle for me on this kind of writing pad. But if you have, so it will be 4 centimeters long. So if I get one of these straight line things out, hopefully this incorporates. Oh, it is. So 2 and then 4. We know the height will be 2 centimeters. So, and it goes like there. So this is just me copying the front elevation. Then if we kind of draw another line. And then another. So this is me just, this is just copying that first shape. So now we've got that. We know that on the side, so it's 3 centimeters deep then. But we also know, for example, and we know that 3 centimeters, this is kind of a rectangle, right? So the bottom is 3 centimeters and the top is also 3 centimeters. So we'll try. This doesn't have to be, of course, exact. It's a sketch. So we'll just try to do our best here, and then we'll label the lens. But important thing to remember is that that kind of this bottom thing is the same length. These two will be the same length. This looks a bit long, I can't lie, actually. So if I actually I'm just shortening this a bit just so it's a bit easier to sketch. Then you copy this one in. Sorry, I do feel like it ought to be a bit longer, just in terms of dimensionality. So yeah, you have something like this, and now this line again will be copied over because the top is a rectangle. A rectangle, as you can kind of tell, and then we can just stick that there. And now we just label the lengths. Perspective-wise, this doesn't look perfect, but it does the job, doesn't it? So we know this is 4 centimeters. This is going to be 3 centimeters. And this is 2 cm high, and by that we've done the whole thing. So I know maybe my explanation wasn't the best, but this is kind of it's hard to explain visualization sometimes, but what the approach I take is just basically kind of looking at this as a puzzle piece and just trying to fit together the stuff. Usually doing the front and the side elevation together. If you do that first, and then you can think about how the top-down view will then work, I guess. So if you use these two, that's what I tend to do, use this one, and then you can see what works here. And this is going from these 3 elevations into this. The other thing you have to do is go from 3D shape to this, which is the next question. Which is what we have to do in this question. So the diagram shows a square-based pyramid with a perpendicular height of 400 centimeters. On this centimeter grid below, draw the plan and front elevation, and look, it's helpfully labeled what the front elevation is, because you might be getting confused between this and this. Of the pyramid, use a scale of 2 centimeters to 1 meter. So first thing what we do is we convert this this kind of the scale thing into the kind of, so we take the 400 centimeters and we say how much it will be on the grid. So we know if this is 400 centimeters, that's 4 meters. So on our diagram, that must be 8 cm then, by using this conversion here. So this should be 8 cm, and same thing here is 6 cm, and we won't really need to use this, but we can just label it 9 cm. So first thing to do is, I like to do the front elevation first because it's usually easier to visualize. And you can just see the front elevation is just going to be a triangle with the base being 300, because remember it's a square base pyramid, so that's 6 cm here. And the height's going to be 400 cm, so 400 cm, so 8 cm on our diagram. So we can just draw that quite quickly. So we know 6 cm long, which is 6 of these. 1, 2, 3, 4, 5, 6. And then 8 cm high, so I think that should cover it. So, of course, you do this with a ruler, and I'm just going to do the best I can here. 1, 2, 3, 4, 5, 6. And then 8 cm highs. 1, 2, 3, 4, 5. Didn't leave no space. So if I just move this, ooh, that is incredibly annoying. It's not cooperating, I'm sorry. I'll just move this down here. So 1, 2, 3, 4, 5, 6. Nice. And then 8 centimeters high, so that's 1, 2, 3, 4, 5, 6, 7, 8. So it'll come up to here. And of course you go kind of midway. Okay, I do not know what this thing is playing at. I'll just do this freehand as kind of best as I can. Of course, please do use a ruler when you do this yourself, and then you get something like that. So then, of course, label. You don't actually have to label because it's on the grid anyways, but I'm just going to say this is the length here, 8 cm and 6 cm. 8 cm, 6 cm. And now the front elevation, sorry, the plan elevation. Remember, whenever we have kind of a change in kind of the gradient of the shape, we should draw solid lines. So if we look at kind of what from the top down view, what we'll see is kind of, this is just requires a bit of visualization on your part. And if you're struggling to do this, try making a square-based pyramid and look at it from a top-down view. But in general, when you have a top-down view, you basically see the thickest part of the shape. So if you have, like, going back to my deodorant bottle, the top-down view, if you have a planned elevation, you're going to see the thickest part, which is kind of up to here. So you don't see, of course, you'll see this point here, and you'll see this, and you'll see the up to kind of thickest part. But you won't see kind of, necessarily, this kind of thin part over here, because it's being blocked by this thick part, and you're looking from the top. So you just look at kind of from the top down, and you see the thickest part, and you'll see kind of what you might want to see. So in this, the thickest part looking from the top will be just this base pyramid, the base of the pyramid, and because it's not, it's not covering anything beneath or anything, that is the thickest part at the bottom. So we'll be seeing some sort of square at the end, but we'll also be seeing some sort of solid lines because of the change in gradient, and this will be in the middle of this of the square and kind of going to each of the edges. So what we'll do is we'll draw a square out 6 centimeters by 6 centimeters. So 1, 2, 3, 4, 5, 6. Is that 6? 2, 4. Sorry. 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6. Ooh. 6, and then in the middle, I think that's the middle, and then we'll see something like that. We see something like that. That's so, and of course we should label this plan and elevation, front elevation. So yeah, questions like these, I've personally found them very tricky. And if you do find them tricky like me, try doing loads of these questions, and that's the only way you can get better at these, I think, is if you just do these a lot of the time. And sometimes what's helpful is actually if you, it sounds a bit silly, but actually, pick up a 3D object in your house. It might be, I don't know, I've got this piece of tape here, for example, or whatever you see, especially something like a mouse, right? It's a bit of a weird shape. So try seeing what the front elevation, the plan elevation, and the side elevation will be, just as a way to practice this. If you're really struggling, that is, I think, a worthwhile thing to do. But hopefully that all made sense, and I'll see you guys in the next video.